Hello, everyone out there. Welcome to episode 3 of The Net. This is the new podcast that we've started. Myself, Kyle Mestry, Brent Salisbury, Dave Tucker, Tom Nadeau. This is episode 3, and today we are very excited. We have a very special guest today. He was excellent enough to grace us with his time for this, so we're very excited to get to talk to him. Mr. Dave Ward. Dave, would you like to tell us a little about yourself?
Well, sure. It's great to be here. I miss you guys a ton. We never get together because there's no such thing as a conference anymore. But I'm extremely happy to be on the Prime podcast. Well, at least a Prime numbered podcast. And if folks don't know me who are listening to the podcast, I'm now the CEO of Packet Fabric. But I spent 25 years of my career building networking equipment, 20 years at Cisco, a couple of years at Juniper. I've actually been at Ascend and even startups before that, Internet Engineering Group, and even Netstar. But it's great to be on as I like to say, the other side of the router. When you're in vendor land and you're building routers and you're inventing all sorts of crazy protocols and operating systems and network operating systems, it's a fascinating life to be an engineer. And you really wonder, why is it so hard for our customers to use these awesome features we just came up with? And how come everybody doesn't get it? Well, when you get to the other side of the router, it is a totally different ballgame, managing, running, orchestrating a live network. And I needed to come to the other side of the router to really understand. And Packet Fabric is an awesome startup. It's kind of in a new category of space. The category that most people are calling it is an SDN company, because we're a cloud-managed, secure, private internet fabric that is SDN to the boxes, an API layer on top that customers interact and can real-time program, orchestrate, provision, get telemetry data, increase, decrease bandwidth and connectivity and interconnectivity on demand with a cloud consumption model. So all this stuff, and I'll say this to all of you on, all my hosts on this podcast, all the things that we've been talking about for going on about 12 years. Couldn't get it done in vendor space, and so I had to just go try and get it done at this startup in Packet Fabric, and it's a great company to be at. So thanks, guys, for having me here. Like I said, I miss you a ton, and what's going on in your world?
Hey, thanks for being on to begin with. I just wanted to mention you being on the other side of the fence. You reminded me of remember what I called when I was at BT? I did the same thing. I called it Service Provider Summer Camp. So maybe that's, this is your summer camp experience. Being on the other side.
I'm not at a giant PTT. We're still a nimble startup. We just crossed the 100-person barrier. Let me just say, if BT is in a PTT telcos at one end of the spectrum, we're kind of at the other end of the spectrum of both technology and how we go about doing stuff. Nothing against BT. I got a ton of friends there and love the company. But nonetheless, we're absolutely trying to do something fundamentally different than how telcos currently manage and operate their network and the services they provide.
Well, so I think that's the interesting thing about, you're not dragging along 20 years of baggage, right? So you're getting to step out and do, whatever you want on this kind of green field, as opposed to, carrying along 20 years of bad decisions.
Well, it's not only 20 years of bad decisions. It's the architectural trap of legacy OSS, BSS, architectural trap of legacy EMS. And honestly, we all together, and we'll probably talk about this some more, worked through, quote, the SDN era, where we invented a bunch of protocols and APIs into operating systems. And we had this notion of controllers. We're not using that architecture either. Now that's now a legacy architecture for different domains, and moved immediately. And I hate to use a lot of buzzwords, but there's a couple of cloud-native containerized orchestration and management system that looks nothing like your uncle's or grandpa's element management system or OSS of the past. And frankly, it looks nothing like the controllers that we all built and worked on together But got to remember, that was about 8 years ago now, 8 to 10 years ago,
Yeah.
that we were really working in that realm. And we all learned a ton of it's the pros and cons of having a centralized, and I can remember debating logically centralized yet distributed controllers. We're not using any of that. And those really aren't the principles that would ever run a network as a service company like we have for the accuracy, precision, and timing.
And isn't that interesting how like all that stuff that we spent millions of human years building is now just kind of like a feature that's intrinsic to your situation now. I was actually observing that same thing about a month ago. We were talking about Kubernetes and the SDN functions in Kubernetes, and they're just there. It's not like a big deal anymore. It's more like a table stakes functionality, right?
Well, I've got to admit, there aren't that many people that have figured out how to run a big scale-out network in a cloud-managed, orchestrated fashion. A lot of the tools are there, but look, the engineers that we hired in were folks that had done previous generations at other companies and other service providers and other startups and other data centers and other folks. And I'm going to put it this way, Tom. We all get smarter by, frankly, making mistakes and building things, and it's an iterative process to get to the architecture that's going to work. And we probably knew in the front end of this 12 years ago when we were just talking about SDN and the power of programmatic networking, where it could be. But man, oh man, did we all, every one of us, have to work and build through a lot of different design patterns to get there. And it really, I kind of take the collective knowledge of all of you on this call, and what I went through was literally just learning by building, implementing, and trying different design patterns and understanding the limitations, not only of the tools, but frankly of that design pattern that we chose.
Yeah, we didn't know what we were doing then.
That's it. I like to think all of that experience
Yeah.
was just that. It was experience. There was, how many controllers? I think we talked about this on a previous episode. There was so many different controllers. They were all roughly doing the same thing, but it was more like an experimentation era. We're all just kind of learning how these things work. Dave, like you said, centralized, distributed, somewhat distributed controllers. All of these things were things we just had to learn, I think, over the last decade.
And we didn't know what we were doing. Dave, you remember when we were still starting to do this, right? There were still people saying, oh, route servers, oh, that centralized thing, that's crazy. You can't make that work right. And we've learned that, not only you can do it at scale, but the tech had to catch up with it too. Computing was at a different place 12 years ago, right? We just have more tools at our disposal now, right?
Well, the other thing, not only do we have more tools and do we have a lot more open source code to be able to base this on, our notion of state machinery and the design patterns of something comes in the top and it rotates through a big wheel of state machines and actions are done out to different boxes or different services, as the case might be. We don't use that. We don't use that anymore at all. We don't even think of using this giant synchronous or even circular state machine like that as an industry. To take it another step forward, 10 years ago when we were building controllers and you talked about the number of controllers, we still were arguing, is there more than one protocol that can talk to the boxes? And I think collectively all of us worked on a controller where I think the single goal of that controller was to prove that nobody cares about the protocol talking to the box. Use them all. Invent new ones. It just doesn't matter. Just get the job done. It's a brass screw versus an aluminum screw. Use the right one for the right job, and that's all that matters. But then we realized that all of these centralized state, and then even stepping to external brains controlling devices, and I can think of, even though this really dates me, the notion of a virtual route reflector. A virtual route reflector, we had spent.
Remember what a big deal that was to make that work? Yeah.
Well, here's where I'm going with this, Tom. Do you remember how many years? I think it was about 8 years it took us to actually deploy something called optimized route reflection, where the route reflection server calculated on behalf of the client and sent them the routes from their view of the topology instead of the route reflection server's view.
Yeah.
These algorithmic changes, they did take time. Look, we are talking about the internet. We cannot have routing loops. We cannot have black holes. We cannot have massive failures. But at the same time, it is all iterative process. It is an iterative process, and it does take time to build through this, which is frankly how I think a lot of organizations that are out there today, or had been out there, we're in a pandemic, but had been going, might not have that much life going forward. And I say that because they're really based on an architecture of many, many years ago, and whether they're standards bodies or open source bodies, haven't been able to keep up where the industry is going, because all of us who are now out in the industry, and I'm pointing to not only the audience, but I'm really pointing to my host or on my computer. We're all now at different companies and moving around, trying different design patterns to solve this problem. And there's a lot of us out there, because anybody who's gone from a networking developer, and I'll call that out of vendor space, moving into net ops, moving into net dev, and then of course now there's net analytics and net analytics developers out there to understand what's going on in the data, the telemetry, keeping an SLA, and just being able to operate this thing. So a lot of folks out there, tens of thousands, if not hundreds of thousands of more people changing their careers to where it needs to go, versus wanting to stay in the constructs of even the near-term past, being within the last, 8 to 5 years.
Yeah, one thing you touched on at the beginning too, we were joking a little bit about the inertia at service providers, but there's also the inertia that was at the vendors, prevented some, or not prevented, but really retarded the progress of this kind of stuff, right? It was just, they had a good thing going, right? And it was hard to break away from that. And now, like you were just saying, like, we've gone to different places now where they're willing to take a different approach, and that's actually been really important in fleshing out some of this stuff, which we've discovered some of it really isn't that magic after all. Some of it's just stupid stuff we fought about, like, and that standard thing you mentioned too, like people wanting to standardize APIs and API descriptions. Now we really realize that's kind of ridiculous. It is what it is, and we got to go with the flow. But that's one of those things that we learned that was critically painful for me, even at my last gig, where we had customers yelling at us saying, no, I need a standard API for all of this stuff. And I didn't quite understand what they wanted, Like, it didn't make any sense anymore to me even,
Yeah, I mean, so early SDN for me was on, kind of the operator customer side, and it was all about how can I save money on hardware by having a common interface to program my network into, right? And that's where I kind of like got definitely wrapped up into Kool-Aid to some degree around, things like OpenFlow. Yeah, OpenFlow wasn't perfect, but it was at least, this was me convincing myself at the time of this, a lot of it. It might not be perfect, but it's an API I can write to. But at the same time, you start to lose sight of what is the problem you're actually trying to solve. Like, is my problem a MAC address being able to talk to another MAC address on a VLAN, or is my problem managing this, unruly network that doesn't get life cycled as much as it should, and costs a lot of money in order to maintain some semblance of uptime? And so I remember, like in 2009, I think, Dave, looking at notes from the Clean Slate Stanford project, and you were in the room, so like you were legendary being there at the original. I actually did a blog post on this years ago, and it was like, here, because it was this kind of like brain trust cabal, is how I looked at it. Like, these are the guys that are making it, guys and girls that are making it happen. You had you, Shanker, all the kind of Stanford, Berkeley legends in there. But it was like, how does this get disseminated to, some random guy in a comm closet in the Midwest? And it was, kind of through those, the breadcrumbs. So, like, what were those early days like?
So it was an interesting time, and it's a bit of a lengthy story, but I'll try and, land on some lily pads to have it make sense. As Tom said, the vendors were doing everything they could to stand in front of programmatic networking. And even though we didn't do it well, we had tried to create programmatic interfaces into iOS XR back into 2004, and it didn't go very well. The tools that were in front of us at the time, and it never really picked up at all. There's no other way to say it. So for the love of God, I did not invent SDN. There were attempts to make programmatic operating systems earlier than the OpenFlow piece, but it didn't go anywhere. So when the OpenFlow pieces came around, and every analyst on Wall Street was saying, this is going to destroy the networking vendor's business. Look, the vendors, back in those days, whether it was the various operators groups or NUGs or, these cabals happening at Stanford, the vendors weren't super welcome because they were doing everything they could to sling it right back that it wasn't necessary and it could be solved. But, for better or worse, I'm willing to go into those rooms. I'll paint a big target on my chest. I'll be the one from the evil vendor, but at the same time, actually trying to communicate with people and move this whole thing forward and understand where it could possibly go and what it could possibly do. So going into Gates 104, there weren't a lot of people who wanted to sit around us, if you recall. Like, there's a lot of popcorn flying our way and a bunch of other stuff.
Rocks.
But at the same time, we were trying to actually make it move forward. And part of the SDN piece was at the time that I transitioned over to Juniper for a couple of years, and we were more successful at opening up the APIs to Junos and to those pieces. But at that time, there was absolutely no interest in going forward through the portfolio. And, a couple of years later, I still working through the Stanford stuff and trying to define OpenFlow and really trying to add value that what OpenFlow did effectively was ACLs with policy-based routing. ACL set PDR. That's all it was doing. And I'm like, these boxes, even the cheapest, lowest end ones, do so much more than that. When you design a protocol, and, I had a bunch of experience doing a whole lot of routing protocol stuff, trying to educate folks on the difference between semantics and syntax and understanding how to overload state machines into the protocol machinery and the failures that can happen there. And that's, if you recall, that's where things went really quickly from 1.0 OpenFlow through 1.1, 1.2 to 1.3, where some of the stuff was teased apart because even those who were deploying OpenFlow, and maybe this was you, Brent, as well, immediately were running into issues that the protocol wasn't going to do what you wanted to do, and it was controller du jour. So anyways, as I was moving back I decided to go back to Cisco. That's a different story. And when John Chambers was the CEO at the time, and Cisco had done everything they could to stand in front of SDN, just to make my argument, back in 2012 or 2011 at that time. And I said to John, I'm like, John, SDN allows the customers to put more traffic onto the boxes faster. They put more traffic, they're going to need more ports. SDN equals more bandwidth equals Cisco selling more ports and boxes. And the light bulb went off. And he's like, oh, this could be a benefit to us. I'm like, and I explained to him, like, you have been thinking about this literally on the complete wrong side of the coin. Your customers get to place more services and get to deploy more bandwidth. It's going to be good for vendors. Embrace it. Don't extinguish it. Embrace it and go forward and take it much further than it ever was before. And in reality, that's what caused a light bulb at least to go off in my head to say, OpenFlow, Yang, GSMP, a zillion other protocols that currently were in existence that could talk to these boxes were SDN protocols. And what needed to happen was that the data structures needed to be normalized so that way it could be then transformed into whatever protocol was talking to a box, whether it was a cable modem system, a BNG, a big router, a little switch, or whatever the case. That became Open Daylight. And Open Daylight's claim to fame in my rearview mirror really showed the industry that there's room for a lot of different protocols, and there's room for SDN operating in a lot of different positions in the network and performing a lot of different functions in the network. But it had to be that it wasn't the APIs that had to be normalized. It actually was the data inside the database, the provisioning database that you're trying to access to, and then potentially a telemetry database. We'll get to telemetry in a second, and then just transform it into the protocols. So we all kind of worked on that design pattern for a while to prove that out. And that was one of the main things that moved SDN forward, I thought, at that time. But what I skipped over was there was only one person from the vendor community who was showing up at the NUGs and NOGs, who was willing to paint the target on their chest, take the tomatoes that vendors hadn't been building, what the network operators were demanding that they were building, and that there was going to be a backlash either to white box or there's going to be a backlash to different protocols and non-proprietary stuff. And you kind of got it. Like, if operators just wanted to make running their networks easier, and they were basically network developers coding to what they wanted the network to do because nobody was ticky typing, and and many different positions in the network weren't using these giant element management systems. It was pretty clear that the industry was going to go this way, and those tools had to be there. So that's how we really ended up moving this forward through the open source movement. Because, and now I'm going to talk to Tom for a second, because there was not a standards body on the planet that was interested in defining either protocols or looking at controllers or defining state machines. There was already SNMP.
Yep.
And so therefore, what more did you need than SNMP? It was a perfectly defined protocol. You just needed to implement it appropriately and completely. And we needed more MIBs in the world more than we needed more ways to program the network. Right. And it was nothing but backlash. We made zero traction after birds of a feather or BOF after BOF after BOF. We went to different standards bodies, and there was just no traction. There was conference du jour.
It was excitement
people
like crazy.
Talking about it.
Remember that meeting at the ITF where like 1 million people showed up, but like.
Yeah. Well, everybody wanted to talk about the glory of software-defined networking and standards bodies, but nobody wanted to do the work.
Nobody wanted to do it, right.
And so what it came down to, we went to open source, where it became very, very clear that if you want to get something done, you got to have code, and you need to have people like-minded with you who are willing to put in the effort to prove out a design pattern or prove out that another design pattern doesn't work or whatever the case.
But remember at the time, though, how uncomfortable it made a lot of people, including operators, because it was not a thing you could nail down per se, and it sort of gets back to that thing about like, oh, there were no standards for this, but that's okay. We found another way to do this. That's maybe more effective.
I think there's a couple of other things going on at the time, which is people wanted to learn more about the quote movement. People wanted to learn more about what we were talking about. They weren't going to do anything until they understood it. They weren't going to understand it until they could see it actually running. And it preferably, they wanted to be able to contribute and work in the code to solve their own problems, because there was a bunch of folks, whether it was Brent or it was Dave T or it was a slew of other people who were like, I've got the same problem as Brent. I don't know how to get out of this. What if we just got together and tried to solve it together? And that's effectively how open source works really well. And then the telcos kind of came along as well just to learn.
Right.
I had this old kind of cheesy cliche, which was, I can't go any faster than my customers, and my customers can't go any faster than they understand. So I better jump to where I can teach my customers and learn with them at the same time if I want to take them in the same direction that we want to go, and that direction was programmatic networking at the time.
Yeah. Yeah, and you remember too, like, I mean, this is kind of a flash forward to where we are today, where there's a lot of customers realizing, telco SP customers realizing that this is actually harder than it looks too. I mean, participating is a bunch of different, you can participate in different ways, right? So you don't necessarily have to, and remember this was at the beginning of ODL, where, the telco operators showed up at this thing and went, wow, this is fun, but I don't know how to participate in this thing. I haven't written code in 10 years or whatever, right? And that's another thing, like to your point about like jumping ahead and getting them to understand where you're going. It also goes hand in hand with them figuring out how they're going to participate in the party going forward. And that is a thing I'm seeing changing all the time,
Yeah, for sure. When, and I'm going to go back to something Brent said, which really rang home with me at the time. The entire conversation was around how can I save money, whether it was on boxes or it was on operational staff. And to this day, even when we look at now where network function virtualization is gone or containerized virtual networking, the security functions have gone, the conversation is predominantly around how can I save money instead of how can I make money. There's two sides to that coin, and if you're to build a system that's focused on delivering services to your customer, and you're going to use the principles of programmatic networking and use boxes in different ways and different size boxes for a different position and function and network, you're going to save money like you want to, but instead of focusing on not delivering anything new to your customers, focus on the services they want to buy, and the services they want to buy, as far as I'm concerned, are real-time reactive networks. And being able to... Good.
I was going to say, I remember too, in retrospect now, one of the things I've really appreciated, and having many conversations with our friend Ken Gray along the way too, is that the cost thing was almost a red herring. The vendors could lower the cost to a certain point, and it was just sort of it was a almost a distraction in the sense of the capex cost. Like the opex cost is really the thing I think you're talking about, which is, and that's the gift that keeps on giving. Once you bought the equipment, you got to figure out how to run it now for whenever. And making that actually adaptable and achievable and the lowest cost possible is, for me, was a real kicker in all of this. It's not like that we have top of rack switches that cost $6,000 or $2,000 now. I mean, that's nice too, but it's that operating these things on a scale is programmatically is the key.
Yeah, and I think what you're saying, I'm going to use different words. The target of going after hardware vendors to make SDN a reality was almost the wrong target. It needed to be at the operational systems that were happening inside, and those often are totally different suppliers, vendors, support systems, and solution integrators. But it was a beautiful circular argument of solution integrators can't do anything until there's an API. So therefore, you have to push here to make that happen, and hopefully a butterfly effect happens, and poof, everything's programmatic. I mean, that kind of seemed like the way the industry was going back then, and it was tough. It was tough as a vendor to ever deflect any of the the bile coming our way, because we weren't delivering at that time the APIs and programmatic interfaces that were necessary for any controller. And now, unfortunately, what ended up happening, even though you said you had a podcast, which I guess would also be a prime number podcast as well, but not as good as number 3. On the plethora of controllers, literally, that's again a layer that nobody sees anymore. You're buying in a controller, you're buying into a design pattern of a state machine of provisioning and how it works and how the high availability is going to work of that software design pattern. And then you're going to have a different, or maybe it's the same, but most often it's different, a different way of collecting the data out of the boxes to be able to run it. Because as Brent knows, and although he didn't go this far in the conversation, you got config and provisioning, and you got the data coming out telling you how this network's actually operating and how it's functioning, and are you meeting your SLA, and what's broken, what's failing, or whatever the case. The two go hand in hand. And don't forget, a network is a billing machine with flinging packets as a hobby. And, the billing machine's got to be accurate, and it's got to be correct, and it's got to be delivering an SLA, or people won't be paying that bill.
What's interesting, too, is like we're talking about kind of like how we've gotten to where we are today. If we look at Kubernetes today as a platform, it's got a lot of those things in it now. They're just intrinsic.
It is the controller, right?
Right. It is the controller.
Is the controller.
It is the gathering place. It is the scheduler. It's an interesting transformation that we've realized, like for DevOps and NetOps and things that work at scale, this stuff has to be part of the platform. You can't glue it on after,
Absolutely. Now, I am going to disagree, only because the previous SDN conversations were frequently only limited to a data center. And I did think that was a big mistake for limiting the notion of programmatic networking just to one. I realized that the market was exploding in a positive way of people building mega data centers, and there's multi-hundred megawatt data centers still being built all over the planet today. So by all means, like, data centers are important. That's not my point. My point is you can use programmatic networking for WAN, you can use programmatic networking at a distributed edge in the enterprise for doing Wi-Fi and wiring closet switches and all the rest of it. And here's what I'm pushing back on. Kubernetes is not PFM and perfection for creating programmatic networks across all those functions in the network. It's good at what it does, and we should never confuse ourselves with a great functioning tool in our left hand that is going to work perfectly, in another
for
situation.
Every nail that we find, right?
I agree.
Service. Go ahead, Kyle.
No, I'm going to agree with Dave. I think that's the problem, and you see this pattern repeating itself. And Dave, you phrased it really well, right? We have a tool over here that does this one thing really well, Kubernetes. Hey, let's move it over here and make it do all these other things, right? And that's where you go off the rails, And now the thing
Yeah.
that it did do well, it no longer does well because you're trying to make it do everything. So I agree. I'm not on board with the Kubernetes as the everything at this point.
And look,
And
this is coming from
that's not what I
this
was
is coming
saying
from
either,
a
by the
service.
way.
Yeah.
Oh, but no, but we're putting those words in your mouth. So now you're the bad guy on this one, Tom, and we found our bad guy for the podcast.
It's perfect.
I'll be the
That's
villain.
right.
I'll be the villain.
But
Yeah.
what's interesting that, Kyle, you say that because you are Captain Service Mesh. And, Service Mesh is perhaps now the most powerful design pattern coming out in software-defined networking. There's no other way to say it. But it requires a whole lot of different types of equipment performing different functions, moving around all over the place, and something to be able to keep track of all that and what's going to be emerging. And I know that there's a whole plethora of tools to do this. How to find out where this stuff is, how is it functioning, is it alive, is it dead, is it meeting my SLA, and the rest of it. But going down the path of Kubernetes and perhaps you're going to allude to Istio or other service mesh technology, it's caused the industry right now to actually centralize cloud services for networking security. So I'm going to just stay on the networking piece for a second. So we see the rise of a lot of security clouds out there, and there's a number of vendors who are making this, who are doing these services. And we see the rise of not just security clouds for traffic scrubbing, but whether it's DNS or it's other services as well. At best, that is just a distributed hub and spoke model. And so now we are looking at what are the traffic patterns? Am I VPNing into them? Am I going down a zero trust networking path where I'm going to start doing split horizon or split tunneling based on these pieces? Where is my traffic going? How can I determine the user experience? In the situation we are now, we know that the employee base of enterprises is fully distributed, and the campus architecture and a hub and spoke of campus architecture is not relevant. And we've recently added to that distributed hub and spoke of these service clouds, of which now we're really just trying to get to the enterprise application cloud anyways, right? I mean, that's where all our tools are. Everyone's doing business up there or is on the way of doing business up there. So am I tromboning traffic? Am I shoehorning traffic? Where am I dropping packets? What's the SLA going through these different pieces? Which is why, even though it's been just a farcical conversation to date on distributed edge, what's interesting when you also think about the tools we have, we'll take Kubernetes and Service Mesh, and now I want to take these centralized security clouds and push them out all the way to the CEOs and deliver networking and security services. That's an awesome, and it can also be CDN, that would be a network service. That's an awesome architectural change for the internet and a valuable conversation for what distributed edge can do and deep distributed data centers can do, or deep distributed cloud. But it's unclear. Even if I can orchestrate one of those pops with Kubernetes, I dialed it all the way back to the point of this conversation. Even if we dial those pops all the way down to one service mesh instance, how am I going to be able to do this at scale across, let's say, hundreds or single thousands, or if you're at a telco, tens of thousands of points of presence that would be delivering the service and make sense of it? So we've got a great tool that operates doing a job very, very well. And we're just on the verge, the way I see it, we're just on the verge of spending a few years of then how to take those distributed clouds and have them function, operate, and be visible as potentially a large centralized cloud, or at least have the systems to be able to do the multi-tenant distributed data collection. And I'm going to look back to Brent and Dave T for a second. When you guys were building those networks, you had centralized data collections, that you had rules engines that you ran against, that you were looking for certain things. It's not your uncle's cloud data center anymore, right? They're smaller distributed data centers all over with customer traffic going through, and the bill is based on this customer traffic, not necessarily on the application that you're delivering out of the cloud. It's a different kind of see that the puck is right in front of us, and that's kind of where the industry needs to skate. So Kyle, get going faster on the service mesh. So
yeah,
well, what's interesting about? Go ahead, Carl. Sorry.
I was just I was going to say that I was going to ask you, what you thought the catalysts were going forward, but I think this distributed edge is clearly one of them. I think it's worth discussing as well. And look, like we're currently so in my day job, I'm working on this kind of cross Kubernetes service discovery almost to some extent, right? Because we have different Kubernetes clusters that we have services running in, but the things that talk to the applications running in Kubernetes are not in Kubernetes, they're elsewhere. So, how do you do this service discovery across these? And Dave, it feeds right into your point as well, because these different Kubernetes clusters might be in different distributed data centers, around the world. They might be in different cloud providers, regions everywhere, things like that. So how do you do this sort of distributed service discovery as well? And it's an interesting challenge, right? And I can't remember who said this. It's one of the famous quotes that I'm sure everyone sees on Twitter, right? But you always want to make state someone else's problem. As a software engineer, if you can do that, I think you've done your job really well.
But Carl, we already know the answer to that question. It's BGP.
Yeah, exactly. Of course, exactly.
Put it in the dump truck and let's go.
Look at that. Brent he's on board with this.
But Dave, I was going to say, like, as you were describing what you're describing, you were reminding me of some conversations I've had recently about looking at service mesh, and that it's just another networking problem in a lot of ways, right? It's a virtual network, and you're virtually interconnecting. What you just described, I mean, are you going to have one blob? You're going to have multiple blobs as islands? I mean, you bring me back to when we were inventing L2 and L3 VPN. There was the same conversation: service discovery, endpoint attachment, scale, and, it's I guess the more things change, the more they stay the same. It kind of falls in that department for me, is that there's a lot of the same problems we're doing, but they just elevated them now to interconnect clusters together. It's a similar conversation with SD-WAN, right? It's a similar thing. It's I'm going to create a giant virtual network, like you're saying, and extend trust out to the very edges, something we've been talking about since MPLS days, right? Doing, SD-WAN, or not SD-WAN. Remember it was called WAN optimization way back when? Same problem. Very similar problem, anyway.
Optimizing. We have set ourselves up for a next-gen disaster. And I think the industry is really doing its best for a next-gen disaster, but it's not just how to do the config and provisioning of these distributed data centers. I have complete faith Kyle will figure this out, as soon as he's off this podcast, he's going to get back to coding, and I'm good with that. But the next-gen disaster that I see is really the opposite side of the coin of SDN, which was the whole notion of telemetry. And the industry has just crushed itself by not having standardized streaming telemetry, by not having any notion of accuracy, precision, or even discussions of periodicity, meaning how frequently this data is coming out. You can't do a pub-sub model onto this telemetry data coming off the boxes at this point. And there's nobody in standards bodies there's very few. We had a NetConf Yang piece which went very well, and model-driven telemetry is kind of the opposite side of that coin, but it has not come together like the config and provisioning side of this. And what does this mean? One, you can still pull a device faster or more frequently and get better in accuracy and precision from the device itself than you can from the streaming telemetry coming off of it. Second, it moved all the value from the data that's on the box into how do I get it from the multi-vendor network sitting into a common database that I can use, and pushing the ultimate value up to the application space sitting on top of what knowledge can I derive out of this. And so there's been lots of misconversations about the value of this streaming telemetry, when instead it has to be, what insights am I trying to get out about my network, and how can I go about it happening as fast as possible? I'm literally, Brent, repeating your conversation in a different direction of the data coming out of the network, of how to make it easier to operate, cheaper to operate across multiple vendors to figure out what the heck is going on. And so this, I see yet another failure of standards bodies, but frankly, it's not being picked up in open source either.
Well, it's almost like,
how is the industry going to get a situation out of it?
It's almost like it's the same movie again. It's that management crap that's boring.
Right.
You know what I mean?
Well, we've moved the cheese. It's like watching an alcoholic drink themselves to death again. So, the problem. So we got no value really out of like custom forwarding packets, right? I mean, there is some value, but it's fairly niche. The value has always been this policy, this disaggregation that Dave described so well. But we haven't. we can barely manage central points of policy, and now we're saying we're going to disaggregate it to across tens of thousands of nodes, across the edge, across time zones, and we're going to expect for there to be, any chain of trust on a policy that gets pushed out without any visibility
People forget
to it.
why the internet works today. I remind people this every other week, like Yakov's famous quote, Dave. Scales because of aggregation.
And
And
summarization. Yep.
you need an aggregation strategy if you're going to amplify telemetry in massive scale. You can't expect to have a linear sort of approach to that. And it's a sort of back to the same movie again. Like we need people to sit down and have a serious look at this stuff and say, hey, but like what Dave was saying, this stuff is like this is the gold that's in the network too. Like you're saying in the packet generation machine that is the service provider network. This is some of the real value, and being able to pull it out, right?
Yeah, no doubt. I mean, let's face it. Linear thinking is for losers. We want asynchronous, nonlinear, thinking to be applied to this problem. And the reason why I say this, and my tongue is in my cheek, is what we proved, or what the industry proved over the last 10 years, was more people looking at different aspects of the problem, all working towards the same goal, which Brent summarized really well: lower cost, easier to operate networks at scale. The more design pattern tests we get to try out. And we haven't found them yet. And so, Carl, by the time you're done and the industry is done with service mesh, it's going to look totally different than the way you started, and it's going to do a quarter of what you wanted to do, and three quarters of it will do things nobody cares about. Why? Because that's just the way the world works. And development by committee is a very tough thing to do. And I'm not bashing you at all. You're a good friend of mine, but you and I have seen a lot of water go under this bridge, or whatever mixed metaphor I'm looking for. And so what is going to be stepping forward? We know that sitting, for example, in front of service mesh is a half-assed TCP or TLS proxy and a quarter-assed firewall, and nobody's actually, what's defined as a next-gen firewall doesn't do anything you want out of that cloud Kubernetes model or service mesh model, which is a great proxy combined with a great stateful firewall that allows you to do what? Brent, apply the policies you have across, in this case, tens of thousands to hundreds of thousands of different little virtualized forwarders that define your application cluster. And the virtual networking vendor, system, startup, whatever the case, that actually can figure out how to fit within that ecosystem and survive. That last piece is critical, because the Kubernetes world and Cloud Native Computing Foundation has proven that patchwork quilt, man, that looks like a human DNA genomics map of number of different projects, sub-projects, all hanging off onto that piece. I'm not trying to flame them, but it's just very confusing and very challenging to make any money.
It's a reality.
If you wanted to focus just on getting the networking and security piece right for service mesh, it's going to be tough to tease that one apart on how that's going to come together, but it has to. And so that's why, even though there's a number of projects working in that space, Kyle, and a number of different projects working on that virtual forwarder, stepwise forward, the industry will get there. And I am looking for a much better virtualized proxy firewall forwarder sitting in front of those application clusters as a key place that networking folks can really apply the policies that Brett alluded to.
Yeah, and we've been talking about this too. I mean, some of us here and some of us elsewhere, about the virtualized network function quality, like you're saying, Dave. Like if you look at any, open virtual whatever, it has a hard time performing as well as a real version of itself. And it's really interesting, like you're saying. I think a lot more folks with network expertise need to come to the party and help build these things. It's not to flag off the folks that have taken some of these things to where they are, but they just don't know what they don't know in some cases, right? They're folks that worked on virtual switch tech, projects out there that have never built a real switch. And I've had conversations with them about why queuing matters and things, and just like, just things like you're saying, in that traditional model of a state machine with state machines inside of it, you have to worry about this, and you're forced to worry about making that stuff work. And maybe in the cloud environment's a little looser. And I totally agree. Like, this stuff needs to be made better and more resilient. Horizontal
Yeah,
scale
But
is not the only metric.
yeah, for sure.
there's a ton of work that goes up.
And to your point too, Dave, it's interesting that you bring up the whole proxy thing. I've literally spent the last 6 months, essentially working on kind of an optimized proxy for both TLS and DTLS, it turns out, because, a lot of the times, most of this traffic, a majority of it is trending in that direction, right? That it's
Oh yeah.
going to be one of those as well, right? And it turns out it's a really interesting problem to solve, to scale that type of proxy and to be able to fail those connections over without disrupting the user between nodes and that. And it all goes back to that state problem of where, keep little state as little as you can and try to move things around. But and to some extent, maybe that problem is a bespoke problem as well, that's only relevant for, certain providers or certain edge situations. But I think it's going to be a more important thing going forward.
Well, we know it's going to be important because it's the definition of the point of trust in a zero trust network. You determine trust in that proxy. And so the state of all of Tom's efforts on VPNs, and that he spent his whole career on, VPNs are now seen to be cumbersome. And because you can go directly to the application, whether we understand the security behind it, we understand how to do key management, or we understand how to do certificate management, is a totally different question. And clearly we don't. It was kind of a leading point. But we do know that the overhead necessary of fumbling through VPN and potentially not having split tunnel VPNs going to the different clouds I want to go to, and not getting the user experience that I need to out of my cloud apps because I'm going to a centralized security cloud. How are you going to be able to engineer user experience in this model? It's challenging enough to understand how to improve user experience using SIP-based protocols. But now when you're writing SIP over redirects, over proxies, over, to going to multiple clouds in this piece is very, very challenging, which is why, and I don't want to go back to this part of the conversation, but I just kind of need to tie it together. If at the distributed edge, we actually had a notion to be able to terminate that user traffic over their access links and then get onto an engineered and secure set of internet services, things get kind of interesting at that point because the clouds are connected together. So therefore, and I'm not trying to end the conversation, but the reason why I made it over to the company that I am is this notion of a secure private internet with access to the entire internet, yet we have an traffic engineered, latency engineered, and bounded jitter for improving user experience going to public cloud and these enterprise application clouds. Yeah, it sure kind of looks like I'm saying, wait a minute, this is in fact a private internet. That's kind of where things might head. And with the conversations we see of balkanization of the internet as well as now balkanization of applications, we know the internet architecture today would have a big challenge trying to disrupt the balkanization of nation states and their control of their internet or of applications themselves. It's near impossible. And banning applications in a country is just a fictitious way to solve this problem. Tom invented how to VPN and jump over the country and have nobody know it's there. My point's not blaming everything on Tom today. Good friend of mine. It's not all his fault, just much of it.
No, but I think it's fair that we point all of the soon-to-be disrupted TikTok users at Tom, though. That seems fair. Like he can help them out with their.
Send them all here, right?
That's right.
But it's a good point. I mean, it's actually, it ties into net neutrality and a lot of that stuff too, which is like, this gets into the hybrid converged cloud thing, which is, you want to use whatever from wherever, but you want to make sure it's what you are after, and that's the secure and trusted edge. I don't want to pick on different service providers today, but I mean, you can't guarantee that with certain providers today. You just don't know what you're getting, and you might as well rock up to a cafe downtown, and if you're running a business and you have, like in today's climate where everybody's working at home, and Dave had a good point, nation state thing and all that, you want to make sure your stuff is your stuff still. And it's not accessible to everybody, and that your people are really accessing your company stuff, not something else. So this stuff is really important. That ties into the service mesh thing too, which is because that's how we're gluing all this stuff together across clouds behind the scenes. So making this stuff work is critical, you know.
Sure, and we got to realize that, look at, without going through the entire industry shift in healthcare and a consolidation that's certainly occurred of both payers and providers in the United States, we know, given the situation we're in, we need more telehealth. We need more distance health. We know that we need to improve healthcare with incarcerated populations and rural populations, just as an example. That is what the internet's good at, but this does require engineering across the public internet or other types of services that can actually enable those types of services to occur. And Kubernetes isn't going to solve it. Service mesh isn't going to solve it completely, but we know we need to make these steps towards. That's why tying this all the way back to what we were trying to do with SDN, where this conversation started, make everything go faster, make the network do what I need it to do and want it to do, allow me to carve out what I want to be able to do, allow me to operate easier, and allow me to do it cheaper and in real time. And Brett, again, I'm just kind of going through your list of things that you started with at the top of the conversation, but we want that to be able to deliver the services that we now need from society. But are those tools there? No. We need more people to be coding back towards these goals to be able to solve these problems. And so that's why continuing to do things in open source and continuing to do things in standard is necessary to have more people involved. And frankly, allow a lot of folks who may be getting displaced from their jobs to reinvigorate their career with new skills. And there's a ton of work to do. So I certainly hope that I think we've laid out at least, about 100 years worth of work for an entire generations and generations of folks to solve these problems. But hey, networking is where the cool kids hang out. So
I keep telling
look at all of us. Look
all
how
the
cool
time.
Yeah.
I keep telling people all the time.
Yeah, it makes sense, and I think so. Well, Dave, I think we'll wrap things up here. This has been an excellent conversation. We definitely want to thank you for taking some time to have a conversation with us. Like Tom mentioned earlier, I think the goal of our podcast was really, to kind of try to emulate if we're all just sitting around at the bar at a conference or something after a show, just talking. And I think it was a lot of fun today.
Yeah, thanks for taking the time.
Yeah, appreciate it.
Great seeing you folks and talking with you. Dave T didn't say a word. That makes me very nervous in general.
I'm just sitting here bemused. I'm like, that Dave. There's too many Daves right now. What are we going to do?
He's silently judging us all.
That's right.
In his own British fashion.
Anyways, thanks a ton. Stay well.
Yeah.
Talk to you soon.
Thank you.
Thanks a lot, Dave.
Thanks. Take care.
Appreciate it, man.
Thank you.